Welcome back, everybody. So this video, we are going to cover the topic of balancing equations. So to get us started, we're just going to answer the question, why do we balance equations? And it all comes down to the law of conservation of mass. So just like you saw in some of the previous pictures, mass can't be created and it can't be destroyed. So we can't just magically make something appear. So when we're balancing equations, we have to make sure that our reactants are always equal to our products, or essentially the number of reactants are equal to the number of products. So we're going to go through a few examples, and then you'll also have a chance to try some on your own. So I have the steps for balancing the equations kind of listed on the side here, and then we'll walk through a few practice problems together. So the first thing is we just want to count. Okay, so we want to count what do we have on the reactant side and what do we have on the product side. So on the reactants, I have hydrogen and oxygen, and then on the product side, I have hydrogen and oxygen as well. Sometimes I'll draw a little line kind of down the middle to help me keep the two sides separated. So if you want to try that, then that is fine. Remember, the little numbers tell us how many we have. So we have 2 hydrogens and 2 oxygens, and then 2 hydrogens and 1 oxygen. Okay, so our first step is done. So the next step, we're just going to ask ourselves, are we equal on both sides? We can see the hydrogens are equal, but our oxygens are not. So the way that we're going to get them to equal out is if we look on our products side, right? So this is our products. We only have 1 oxygen, and if I want to get 2, right, I'm going to put a 2 there in front. So now we have 2 oxygens. But remember, this 2 applies to this entire molecule. So now instead of just 2 hydrogens, we have 4. Okay, so if I look back to my reactant side, and again, here are my reactants, I can see my oxygens, they are now equal, but my hydrogens are not. So if I have 2, I have to think, okay, what times 2 is 4? So if I put a 2 there, now I have a 4 total hydrogen. So everything is equal. And then remember, if we have a blank here, we know that that's just really an invisible 1. So if you want to write a 1 there, that's fine, but you don't have to. Most likely you will not see anything written there, generally speaking. Okay, let's walk through one more together. So again, we're just going to count. So I have 8 sulfur and 2 oxygen. On this side, I have 1 sulfur and 2 oxygen. So the sulfur is unbalanced. I only have 1 on the right side. So if I have 1 now, I need a total of 8. So if I put an 8 in front, now that gives me 8. And then now for oxygen, right, that means I have 8 of these entire molecules. So when we say the entire thing, I mean, it would be like if I wrote out 8 SO2s. Okay, so how many total oxygens do we have here? 2, 4, 6, 8, 10, 12, 14, 16, right? Or we can just multiply the coefficient by the little number. So that gives us 16 oxygens. So now my sulfurs are equal on both sides, but now my oxygens are not. So if I look at my reactant side, I only have 2 oxygens. I need 16. So if I put an 8 there, right? Remember, we can say 8 times 2, that's equal to 16. So now everything is balanced on both sides. And again, if you want to put a 1 there, that is fine. Typically, we just leave it blank. Okay, let's look at the next one. So I'm going to give you a chance to count out your elements. Now you can check how you did. So 2, 5, 1, and 1. It doesn't really matter the order that you write everything down. I typically like to write mine so that they go like read across. So like the V's are on the same row, the oxygens, calciums, the sulfur. That just makes it a little bit easier to compare things, right? And then I'm still looking at my little numbers to write down like my count. So let's see what we have that is unequal, right? So we have our vanadium, that looks good, 2 and 2, but our oxygen does not, right? We have 5 on the left and only 1 on the right. So in order to make it 5, I can just put a 5 in front. So now I have 5 and 5. But that also changes my calcium, because remember, it's not just 5 of the oxygen, you added 5 of the whole molecule. So now my oxygen is good, 5 and 5 on both sides. So now I'm just going to keep kind of going down the checklist. Now I have calcium. So I was okay, now I'm not. I have 1 on the left, so in order to make that equal 5, I'll just put a 5 in front. And then again, that also changes sulfur. But now that actually fixed the ending, because now we have 5 and 5 sulfurs on both sides. So this one is all done. So this one looks a little bit different because we have a polyatomic atom in here, right? A polyatomic ion. The trick here is we have a CO3, a carbonate ion on the left, and we also have a polyatomic ion on the right, CO3, right? So it's the same thing. So one trick you can use when you're actually balancing this equation is we can actually kind of treat that like one thing, okay? So if I was to count out everything that I have, I'm going to treat that CO3, right, like it's one thing. It's going to make it a little bit easier to count rather than trying to treat it like carbon and oxygen separately. So if I go and look, I have 1 silver, 1 iodine. I have a little 2 there for the iron, and then the CO3, right, we have a little 3 on the outside of the parentheses. So that's telling me we have 3 of those. Again, if I go over here to the right side, I have a little 2 for silver. I have a little 3 for iodine. Iron is 1, it's invisible. And then there's no number out here next to the CO3. So that means I just have the 1, right? So if I had kind of erased all my writing around there, there's no little number. It's just CO3, so I just have 1. Okay. The trick here is that we can if we start with the polyatomic, trying to balance that out, that will help us out a lot. It usually solves a lot of our problems kind of first. And then we can kind of go back and look at anything else that doesn't add up at the end. So if I have 3 CO3s on the left and only 1 on the right, I know that means I need to put a 3 in that space. So now that means I have 3, which will match up. And again, now I'm going to say I have a total of 3 times 2, which is 6 silvers. I'm going to erase that so it doesn't get in the way. Just remember, if we put a 3 in front, it has to be for everything. Okay, so now let's kind of go down and look at the next thing. So we've balanced our polyatomic. It looks good, so it doesn't really matter where we go next. I typically just go up to the top and start there. So let's look at silver, right, Ag. I have 1 on the left and 6 on the right, so I know I need to put a 6 in that spot. and that's going to change both of those to 6. So now let's look at iodine. I have 3 on the right, and I need to make it equal 6. So what number do you think I could put in that blank? If you guessed a 2, you would be right. So now we have 6 total iodines. 2 times 3 is 6. And again, we have to fix the iron as well because the 2 applies to everything there. And then that fixed the iron. So now we have 2 on the left and 2 on the right. So in this case, everything is balanced. So we are all done. I can erase all of this extra stuff that I wrote out. And then remember, if you need to, you can put a 1 there, but typically we just leave that blank. All right, this one is very similar to the previous one. Okay, so I'm going to let you kind of try this one on your own. I am going to give you a little hint. All right, we do have a polyatomic here in O3. So remember, you can add this up like it's one thing. So we can add up our sodiums, add up our nitrates, our NO3s. You can add up your lead, and then your oxygens that are just by themselves, right, that are not part of that NO3. And then we'll do the same thing on the right side. So take a minute to try this one, and then you can keep playing the video and check your answer. All right, so I'm just going to add everything up. I have 1 sodium, and then I have 1 NO3. And how do I know that there's just 1? Because there's no extra little number out there. I have 1 lead, and I have 1 oxygen. On the left side, I have 2 sodium, 2 NO3s, and then 1 lead and 1 oxygen. Let me get rid of all this extra. All right, so now, right, we said that typically we want to start with these polyatomics to balance out, and then we can go back and do everything else at the end. So I have 1 on the left. I need it to equal 2, so I'm going to put a 2 right in front. So now I have 2 and 2 sodiums. And then my sodiums are good, nitrates are good, and then 1 and 1. So this one is balanced out right there at the beginning. So that is the last practice problem. I do have one other tip that will sometimes help when you're balancing. If you save your hydrogens, like your H2s and your O2s for last, if you ever see any of those will typically kind of work themselves out, especially these O2s. Sometimes those are a little tricky. But if you see an H2 or an O2 by itself, if you just save that to be the last thing that you balance, then a lot of times they'll kind of work themselves out and match up automatically by all the other things that you do. Okay, and as always, if you still have questions, make sure you ask.